Okay, this is gas loss review worksheet number 2. So how many moles of CO2 are contained in a fire extinguisher that holds 5 liters at a pressure of 10 atmospheres and a temperature of 21 degrees Celsius? So the first thing you have to do with these gas law problems is make sure on whether you're going to use PV equals nRT or whether you're going to use this form of PV equals nRT where it's P1 V1 over N1 T1 equals P2 V2 over N2 T2, which is really just a situation where you're using the change where a gas is one thing and then something about it changes and you look at what happens to the other variables. So the way you distinguish between these two is if your problem has one of the values, for instance 5 liters, then later in the problem they say it changed to 10 liters or 7 liters or something like that. But if all of the values that you have for each different variable aren't changed, then that's your indicator that it's going to be PV equals nRT alone, and that is the case in this problem. So we will start with the equation we're going to use, which is P pressure times volume equals moles times R, which is the gas law constant, times temperature. Okay, and then basically we just plug into this equation and then algebraically solve. So first we have N, which is what we're looking for, and then R is right here. Now notice whenever you're using this equation and you're using R, you need to match the units of R to your other units. So in this case we need our pressure in atmospheres, our volume in liters, you're going to be moles is going to be moles, and then temperature has to be in Kelvin. So I'm going to go ahead and put R in here, 0.0821, and then next is temperature. Temperature is over here, 21 degrees C, but again you always use temperature in Kelvin, and if you were following my other rule you always match it to what R anyway, so which is Kelvin. So the way we do Kelvin to Celsius is simply adding our Celsius temperature, add 273 to that, and that'll give you your Kelvin temperature. And when you add 273 to 21, you get 294. So that's where I came up with that. And then let's keep the colors coming here. And then let's see. They give us 5 liters, which is our volume. So I'll go ahead and put my 5 in here, and liters of course matches the units of my R. And then the only other unit that we have in here is 10 atmospheres, and again that matches our R, so we're good to go. Just plug that in, 10. And now we've essentially done the chemistry of just making sure we pull the values into the equation. Now we just have to do some math, some algebra. So the way I would do this problem is I would multiply these two together, which would give me 50. Then I'd multiply these two together on the other side of the equation, which would give me N times whatever they are, which is, let's see, 24.1. And then to solve for N, I would divide both sides by 24. So I divide this side by 24.1 and this side by 24.1. And that would give me an N, which is what I'm looking for in the problem, of 2.07 moles of CO2 that is in that fire extinguisher. And that is it.